Now let's talk about open source AI. Why do we like open source AI? It's cheap, it's fine-tunable, and it's inspectable. We're going to talk about the entire stack from top to bottom. At the very top is the user of AI, and at the very bottom is the silicon which the AI runs on. Does this make sense to you? Who said maybe? At the very top are the web chat and the agents, which is most of the way we use AI. That works through the application peripheral interface, which is a REST API. For those interface to the models run on the Inference stack. The Inference stack these days pretty much exclusively uses PyTorch as opposed to TensorFlow or Caffe. That uses CUDA or ROCm. Does anybody know the difference between CUDA and ROCm?
I know CUDA is developed by NVIDIA, right?
That's right.
ROCm, I don't know who makes that.
AMD. Which one's better? CUDA. I interviewed one time with the AMD platform development team. It was for Vulkan, which is on the same level of GPU programming. I asked them about GPU or general purpose graphics processing unit. NVIDIA is the way to go here. Also, some of the groups that I'll talk about later that use these chips, they are all having trouble with AMD. These are the leading commercial models in AI. ChatGPT, Claude, and Gemini. Which one's your favorite?
ChatGPT. Gemini has access to YouTube.
Yeah, probably better for coding.
Prompt Gemini, just open the app, write a paper, analyze Claude. And if I type an email to my coworker, we ChatGPT.
Anybody using OpenClaw? Which AI do you use OpenClaw with?
Minimax.
Minimax, okay, one of the open source ones.
It's the cheapest one out there too.
Right. Benefit of open source is anybody can run it, so they can make it real cheap. There's also some agents, and there's a million agents out there. Claude Code. I did try Kimi Code, because this is a Kimi event. Kimi Code was okay. Most of the time I use Codex for coding. My interest in AI is primarily in coding. Is anybody AI coding regularly?
Yeah, I have 12 agents going on right now. I'll wait to get home and see what they did.
I hope they didn't delete your database.
There's very strict guidelines and dashboards and reports and pipelines, and we're very orchestrated.
Yep, this man's an orchestrator.
I am.
You don't have to get AI directly from ChatGPT or directly from DeepSeek. The open source models will be served on a lot of different APIs. Bedrock is the big one. Fireworks AI, Together AI, and Base 10. These are the favorites of SGLang. Let's talk about the models. So here's the open source models. Llama 4 is a big one, especially in academia. OpenAI released this open source system, 120B, that's how many parameters there are. So you can imagine that as roughly the size it's going to take in memory in terms of gigabytes. Do you have 120 gigabytes of memory on your GPU? You can run it. Gemma, I haven't tried. Mistral, I've tried just as a web chat. Kimi is one of the Chinese ones. DeepSeek was the first major open source Chinese LLM, and you'll see that further LLMs, such as Kimi, are going to refer back to that one. SGLang claims to have high rankings in the benchmarks, and Alibaba is like their Amazon, and they support all kinds of software projects.
Can we talk about that real quick? Because I think these guys trained their models on half-assed, like Claude and Codex models. They say they actually cause a lot of concern, right? Not because they stole the data from somebody else, like, so did OpenAI and Anthropic. By doing that, we've lowered the level of the expertise of these models, right? Right now, we're using these models to create AI slop. That AI slop gets out there, and these third-party models get all trained on this AI slop, which then generates even more AI slop. And we as humans in the end are actually going to play a role is to make sure that the AI slop doesn't fall apart.
Sounds good to me.
Has anyone used GLM5?
Nope.
I heard really good things about it.
It scores well in the benchmarks. Didn't?
Do you trust using the Chinese models on your own rig?
I haven't run these because they're just too big for my hardware. That is one of the safest things to do, though. Is they might phone home. It would be the fear. I don't believe that that is going to happen. No. As far as using their APIs, who knows what they do? OpenAI will actively train on your data and will store it. I don't think the Chinese can get much worse.
I have a map of the world in my office that live tracks everything that goes out of my network. And if I see something phoning home on that thing, I'll know that in 2 seconds. You set guardrails around it and you give them the runbooks to actually keep them from doing what they can't do or what they're not supposed to do.
DevOps Columbia was talking about this, and sentinels and guardrails. I'm going to move forward to the benchmarks. Humanity's last exam, I thought this was a funny benchmark. But But here's how Kimi compares to the three commercial models I shared at the beginning. They claim it did much better on humanity's last exam, ROCm, Deep Search QA, SWE, that's Software Engineer Bench, SWE Multilingual, MMMU, the Math Vision, Video MMU, and Long Video Bench. We're going to take a brief side quest and meet the benchmarks. Here's humanity's last exam. It says, here's a representation of a Roman inscription originally found on a tombstone. Provide a translation for the Palmyrene script. A transliteration of the text is provided, and it has some transliteration. So it's very academic, things like PhD level questions. And the better your AI does on this, the better you do on humanity's last exam. ROCm is all about how well can it browse the internet. So if you have an AI that you want to get a lot of data from the internet, if it does better on ROCm, it might help you out better. Video MMU is all about comprehending like educational videos. And SWE Bench is the software engineer. So they've created software problems. You let your AI on it, and if it can solve the problems, it's a software engineer. All right, we're going to move down one step to the inference stack. Can anybody tell me the difference between training and inference? Okay.
I was going to ask, what's inference?
Yeah.
I'm not sure what that is.
Wouldn't inference be like intention versus training, which would be a large data set?
Similar. Inference is when it runs. So when you interact with ChatGPT, you are getting the inference. It's the mathematical sense of the term. So the result is inferred from the problem. When you actually compile ChatGPT to make it work, that's the training section. So training and inference, which one do you think takes more computational power? Training. It takes a lot. It takes thousands of GPU hours. These are two different steps which result in two different sets of software. We're just going to talk about the inference stacks here. Training is not their focus. Llama is the big one, supported by Meta. VLLM is a well-run organization. Somebody in the DevOps Columbia meeting was talking about meeting with these guys in New York. SGLang is the one that I've been in for a while. At SGLang, if you look up their videos, you'll see me popping up every once in a while. And finally, what is Hugging Face? I still don't understand Hugging Face. But it's just cute. It's a cute logo. I guess they worked on the Transformers library in Python, and that's an inference stack. But these are basically the math behind your LLMs. There's different optimizations that you can do to make sure that they run faster, particularly on the open source LLMs. Okay, these two are in red because we're going to skip them, but do know that they're there. There's PyTorch, which is going to use under the hood, as it were, either CUDA or ROCm, depending on your hardware. We're going to skip down into the hardware. Who can tell me the difference between a CPU and a GPU? Jaden.
GPUs make graphics and then use compute.
Yeah, but AI computes, right? AI is not graphics.
Yeah, but I think the reason why they use GPUs instead of CPUs is if you want to do a lot of simple questions, GPUs are better. If you want to do a few more complex problems, CPUs are better.
That's a good way to put it. The GPUs have a lot more parallelism. So GPUs might be thought of as CPU with 1,000 cores or 2,000 cores. CPUs usually top out around 16. I saw one with 40 recently. I was like, that's a lot of cores. How many cores do your computers have, Mr. Cass?
Depends on which one you pick. I've got a whole stack of things with 4 cores that do stuff, right? But not for my MacBook has 6. Like, you've got CPU, you've got GPU. The bigger problem right now is the memory bandwidth between the two. Take NVIDIA Thor. NVIDIA Thor right now is like an amazing device, costs you $4,000, but it actually has like very limited bandwidth and speed between the GPU and the CPU. What we now see happening is this convergence of hardware coming together. The Apple M5 that gets almost the same performance. Like, I love the time that we live in now.
What a time to be alive. Thank you, Cass. So we're going to meet some of the hardware. NVIDIA, AMD, there's also one called Grok. Not GROK out of X, but Grok that historically made hardware. Well, the major NVIDIA architectures for large language models are Hopper and Blackwell. AMD has Instinct and Grok. There are these things out there called tensor processing units or neural processing units. They have not proven out in market for one reason or another. So we're still on GPUs for AI. The canonical NVIDIA hardware used by SGLang and X, and I believe VLLM, is the H200, sold as the H800 in China because there are some export restrictions there. AMD has the Instinct, which has numbers like MI325. Grok, we no longer sell hardware. So they got into some hardware trouble. Hardware is hard.
No worry, the friend at X is going to build the hardware for us. Right? He's going to have the factory done in 7 days, he said yesterday.
You said yesterday? Elon Musk?
Yep. New AI factory.
We're going to have to talk to that guy. a side quest to meet the data centers. So we've got all these data centers coming, right? Some people are happy about it, some people aren't. The tech community is not necessarily on the side of data centers. It seems to be just a government thing and large corporations. And here they are. Found this on Frederick News. There's 22 in Frederick County, 9 in Baltimore City, 3 in Baltimore, 1 in Howard County, 4 in Montgomery County, 4 in Prince George's, and 2 in Anne Arundel. And I've got them all listed out here using that particular article as a source. And they're all for AI, right? Well, with AI assistance, I looked at all these companies and see, well, which one of them are most likely to have AI? It's these ones that might have the hardware. Don't know if they do, but they might have the hardware, and they're all in the same complex in Frederick. So they'll probably be getting a call from me because our metropolis needs to use them to produce rather than consume AI. So it's Amazon, this group called Align Maryland Hyperscale Campus, Align Data Centers, and Rowan Digital Infrastructure, which I hadn't heard of. Frederick. I've invited Frederick to be part of the Maryland Tech Squad, and just like their music scene, they want to do their own thing. And they don't want to be with DC either. Frederick is for Frederick. That's my impression anyway. Let's meet the silicon process. This is the state of the art in silicon processes. It's a combination of Zeiss, where they make the optics, ASML makes the process, and TSMC is where it's at. The history of TSMC, it is in Taiwan, but they picked up a disgruntled leader.
Texas Instruments, right?
Yep, Texas Instruments, back in the 80s. And he was getting passed up for a promotion. He was evidently the best. They were passing him up, so TSMC picked him up. Not totally a Taiwanese endeavor. Where are they in the USA? We only have a couple that are remotely competitive to the TSMC one. There's the TSMC one in Arizona. There's also an Intel one. Now, Intel is having problems. And I worked there for 2 months. They fired me. They did. They did. I was asking too many questions, but I found out that this company is just bad. The government has bought part of it. Trump made the unprecedented move of buying 10% of the company. The military has invested heavily in this company. I saw just some absolute garbage coming out of the Folsom lab, and the organization of the people is bad, and it's embarrassing that we're not competitive with the East because we're putting all our money into this company, and it's letting us down. Their strategy is like ecological R selection, where you put out a lot of crap and maybe 1 or 2 of it works. So they do have a solid set of CPUs. Their GPUs failed, but they do have some CPUs left. So that's how I feel about Intel. Next time I'll tell you how I really feel. And then there's Global Foundries up in New York. These numbers are lies. Ever since the 1980s, semiconductor fabrication companies just started lying. And the actual size of these gates, it's more on the order of like 35 nanometers, but they call it 4 nanometers. They call it 3 nanometers, which just means like the next generation. Nobody stopped them. So this 18A, that means 18 angstrom. And angstrom is 1/10 of a nanometer, but it just means the next generation.